Welcome, we are Shaper Tools, this is Shaper Sessions, and today we'll be diving into prototyping, how Origin helps elevate your prototyping game. We'll be looking at a range of different industries and bringing it back to woodworking so that we can see how we can exploit regular old basic Origin workflows. And joined with me today is Adi Rao. He's an engineer here at Shaper Tools. There he goes. He's an expert in all things materials, and if you ever need to know how sticky something is or how strong something is, he's the man to turn to. And also we'll have Dylan Fairbanks. He's a principal engineer with a background in mechatronics. So he's over in Oakland. Actually, they're all in Oakland, yeah. But we'll get right into it. Thanks for joining us. We'll have a few interesting topics to delve into, and hopefully everyone gets something from it. Enter all your questions into the chat. We'll get round to them at the end, but for now, let's launch into it. So first and foremost, what is prototyping? Why do we do it? What's the value in it? Adi's going to be deep diving into all these, and then we'll look into why Origin. Why is that really solid, really efficient way to push through a project through the prototyping phase. We'll be looking at the process of developing a product, be it a literal physical hardware product, or even just a woodworking project in your own shop. How that would develop into something that you may sell or mass produce someday. Then we're going to look at how to get the most out of your Origin whilst you're prototyping. Some tips and techniques that might help you in your regular working day. So over to Adi, take it away.
Yeah, thanks, Sam. Hey, now can we go back to the slides? That'd be great. Thanks for that kind introduction. I definitely know about all things adhesive and sticky, but we're here to talk about prototyping. Let's dive into it. So we jump to the next slide. We wanted to start today with this session on prototyping with sort of laying the foundation a little bit about what is a prototype. So at Shaper and personally, I like to think of a prototype as sort of just a simple representation of a proposed solution. So this could be a really simple model of something. A lot of times we call these things mock-ups, a paper mock-up or a cardboard mock-up. But really the goal here is to be able to test and validate your ideas or design assumptions or other aspects of what you're trying to achieve really quickly and really cheaply. And those are the sort of key points. We're going to touch on why Origin is really great for those things. Why do we prototype? I think this is an important question to always ask. Why do we not just build the final product? The goal is really about iterating and testing ideas as quickly and as cheaply as possible, so that when we do get to their final iteration or form of something, we've exhausted all our failures early, hopefully worked out all the kinks, and ultimately what this gets us is reducing risk on a project. The last thing you want is to get to the final product and then realize you missed something. And so prototyping fast, prototyping often really reduces risk by reducing cost and time. So let's jump into the next slide and look at how Origin can really play a massive role in prototyping. I think, like I was talking about, one of the big things with prototyping is actually building tangible objects, and something that Origin is really great at is enabling you to take action towards something rather than sort of spend a lot of time thinking. It's all about going from an abstract idea that you might have a sketch of or even a CAD model of and making it tangible. And that's really sort of the most important thing when you're prototyping something, is actually making the object, is making it tangible so you can learn really quickly. And something that personally at Shaper we believe is that the cost of actually making something with Origin can many times be so much lower and faster than actually thinking about it and spending a bunch of time just talking about an idea. And then we move on to rapid iteration. I think we've probably touched on this many times in past sessions. Origin's a great tool for making many iterations of the same thing, and it's really great at taking a specific idea and modifying it quickly on the fly, even using on-tool CAD features to be able to modify an original idea and make different iterations of the same thing. And another sort of advantage of Origin here is being able to do those rapid iterations with real materials. It might be, an example we were looking at is making cardboard prototypes, and cardboard prototypes are really great sometimes, but it's always great to be able to actually prototype on real materials. And Origin can do that for you in a wide variety of engineering materials, from all the way from simple plastics to soft metals like aluminum and brass. And lastly, and this is one I like to bring up often, is reducing the cost of failures. And what I mean by that is, if you prototype really early and prototype often, you fail early and you fail often. And what that means is you're putting all your failures really early in your project, and that reduces the cost overall of your project, and means that you've taken away all the risk in a project. All right, well, that was a lot of theory, though. So maybe we can get to some tangible prototypes, and go over to Dylan to talk about something he's built recently.
Yeah, so thanks, Adi. That's an excellent introduction to prototyping. So I want to tell you about the details of actually building this prototype. This was a example of putting some electronics that are panel mount into an enclosure in this case, but it could also be in the panel that goes in the back. I come from, the mechatronics engineering world, and I often need to develop something to control a machine or contain electronics that I want to show to people and show how it works, have it completely protected and safe to handle. And so I would prototype with Origin this way by cutting out, arbitrary shapes. All these things that mount to panels, they either have a bolt pattern or they have a circle with keying in it, and so or a rectangular shape. These things need to basically have CNC or other prototyping methods to prove the concept and try it out. And so this box here, we have a round cutout with a key, a circle, and a switch. And so as a mechanical engineer by background, I would go to SolidWorks and I would download solid models and throw them into a model, a 3D model of everything in assembly. And then I would get the outlines that need to be cut onto that face. And the reason why I would want to build this prototype is because not only do I want to make sure the parts fit in the outlines that I cut, but I also want to check the wiring, like room for my fingers or someone's fingers who's going to build it, to be able to work around the components, to be able to route the wires around in an organized way. And this could be a small box enclosure for a microcontroller or a big panel for an outdoor, electronics on a pole. It doesn't really matter. The key is that we're doing rapid testing, like Adi said, where I'll get the parts, I'll fit them in before I go and order 100 or 1,000 from a vendor, or even if we're manufacturing in-house. I will take Origin, cut these out quickly, and see how they fit, and have a prototype that I can share around, show people, get input, and get a better design quicker and cheaper that way. Nice thing about having a box like this is I could actually do leak testing or other validation that I want to make sure this thing is going to do the job that it needs to do.
So you got their McMaster, right? You've found those individual components on the McMaster website, and then they share the CAD, the 3D models that enable you to then extract those outlines and then cut them into the final thing. Yeah.
Yeah, that's super nice. McMaster has models for almost everything in SolidWorks and step files, that you can put in Fusion 360 or any program. And the nice thing there is, they might have some specs on how to fit it, but it doesn't always have everything you need. So the 3D models, as an engineer, really help get everything you need in there, because you need to check not just the panel design, but the fit in the back. Um, so then, yeah, the next slide, I was going to talk about the process for sort of creating the artwork real quick. From the McMaster, I'll pick out the parts on McMaster. I think they're going to fit in this box. I'll get the parts on order. While they're getting ready to ship, I will do the artwork layout. I'll end up making one 2D face that I'm going to export. And so you can see in this picture here, I've actually made a separate body and made a very simplified outline because I didn't want the other holes and rounds on that case, so that when it comes into Origin, it's got a bounding box and it's easy to place using the grid, stuff like that. So yeah, straight from McMaster or other vendors usually have step files. I'll get those into the computer, export that face. For me, I don't do a lot of graphic design, so Illustrator's a little daunting. I use Inkscape. It's free, open source, and there's a couple steps of ungrouping and joining nodes, and then you can color for cutting, and it's a couple of steps, but I don't spend much time in there at all. Basically, upload that one face to Shaper Hub, and then when the parts come in, usually from LA to San Francisco, ground shipping, they'll be here the next day. I can cut this thing in 20 minutes and test fit the parts and iterate that quickly.
That's awesome.
So I think
we've actually, yes, we got one here we can demo, Noah. So that's we should keep in mind that's an engineering-centric approach, right? SolidWorks is a expensive engineering software, and then the workflow works if you're technical, but you can always fall back to simpler and simpler methods. You can always use assist. You could direct them towards the parts you're interested in, and they'll deliver a cut file for you. And there's also, it doesn't need to be full 3D. You could get most companies ship with the mounting template. It might be a PDF or something like that, just an image with a vector that you can then take into either Inkscape or Illustrator and convert to cut files ready to use with Origin. So we got the panel here. It's a little ABS panel lid, just like you saw there. And Dylan mentioned he saved the file to Shaper Hub. So if you can cut down here, Noah, you'll be able to see me placing this, the little side camera. Yeah, so I've got a little block of wood just to support the underside of this because there's a cavity. I can place this here. If I was doing multiple, in fact, I think Dylan did do multiple, he set up a little indexing block so that he could put them repeatedly in the same location. So I'm going to, we'll cut to my screenshot here. I'm going to place the file, and Dylan can walk you through some of the sort of thought processes of what he had going there. So first I'm going to do a scan. Then I'm going to do a grid. So I'm going to identify the physical edge of this object by dropping my cutter down, which, by the way, is it's a 1/16 of an inch O-flute upcut cutter. It enables me to run the spindle nice and slow and get some pretty big chips to avoid melting. So I'm just going to finish that, and then we'll do a grid, and you can talk me through the file once I'm placing it, Dylan. So new grid. I'm just lowering the cutter down. I'm going to use the very edge of this little guy to just lightly touch the edge of the panel. I need to check here. I've got a 1/16 of an inch cutter, so I can actually just type that in with. I don't need to remember the decimal for it. I can type in. Whoops, sorry, 16, and it'll calculate that properly. So as I feel it touch the edge, I'm good, and we move along. So you notice I'm just touching the top edge here because this has got it's a molded part. It's got a bit of a draft angle. and I'm just very lightly touching the edge. It automatically chooses the right edge of my cutter to use as the probe. So now I can import this. This is the Shaper Hub area where Dylan shared his file, and I can grab that right there. So because I've probed the bottom left corner is my 0, 0 and XY, I can rotate this file 90 degrees and then use an anchor point that's bottom left. And that'll enable me to snap. And you'll see that's now nice and centered on this object. So before I kick off cutting, I should mention, if you're just experimenting with new material, I'll do this again. One great technique, so it's going to remind me to do a touch-off. This is just measuring how high the cutter is mounted in that collet. So this is where Z equals 0 is. I'm doing it on a nice flat surface where I can feel see tape, sorry. So if I'm going to test cut this, I can actually do a big offset. So that means I'm never going to, like if I get my cutting settings wrong, I'm not going to damage my work. It's fixed in place with that double-sided tape. I'm going to put on some glasses and just quickly cut this. So it's going to be a bit noisy. Dylan will keep you amused in the meantime.
Yeah, so Sam did exactly what I was intending by including that bounding box in the artwork. Since that part is drafted, I just wanted to touch off the top, just under that round. That's where I grabbed from the CAD file and place it exactly like he did. So, it's not critical that these are exactly, perfectly placed here, but that's a nice way to be fairly accurate very quickly, which is the goal here with this prototype. And so I see, Sam's got a cutter. I didn't have the 16th inch cutter. I used the 8th inch cutter that comes with Origin. It was fine for these parts, but it's not quite as nice for cutting plastic like this. I did do 2 passes in order to not get any melting. You want to run the spindle nice and low, low speed. This is on a 1, and keep that plastic from melting. Also, if you wanted to not scratch the surface, of this prototype, because you're going to be showing it to people, an ID or whatever, that want to make sure it looks really nice, you could cover it with some tape, masking tape or something. So just dragging Origin around on there won't scratch it. That looks like Sam's wrapping up with that already.
What would you recommend for that? Not sandpaper, something to just scuff along the edge, something plastic and hard, maybe?
Yeah, that's soft plastic. I use an X-Acto knife, just clean it up carefully. But
that's a good point. Yeah,
probably good enough to stick your parts in and see how they fit.
Yeah. So then you get your little gasket. Does that go on the top, I imagine?
Yeah, on the outside.
Yeah.
So the round ones have a gasket, and that rectangular switch didn't have a seal. It's not made for waterproofing. I just wanted an example of a rectangular cutout.
But yeah, we won't go through the whole process of assembling the whole thing. But you can see here. What's that? Sorry. There we go. I got another camera here for you. Yeah, that's now a totally serviceable, presentable prototype ready to go. I'm sure the guitar pedal builders will be all about that. Keep in mind, like historically, if you didn't have access to a CNC machine, you'd be like messing around with a Dremel or little files, trying to straighten up these edges, and pretty basic shapes can be pretty daunting, or they fall away from accurate, consistent outcomes pretty quickly. So yeah, to be able to bang that out really quickly is great, and especially using the workstation here. Like even if we did want to compensate for a draft angle, we can like shim something and position it so that the top surface is flat and we can get our cuts done just right. Right, moving right along. We mentioned that same process. Thank you for that, by the way, Dylan. That's awesome.
Thank you.
We mentioned, we'll cut to my screen here, Noah. So we mentioned there is a process here on, sorry, my computer screen, Noah, where we can do it in Fusion. Yeah, so this is Fusion. We have a little export plugin, so we get kind of free color-coded SVGs out of it. With that plugin, doesn't cost you any money. And if we go back here, so I've actually got some of these elements dropped in here already, but I'll show you how to find them if you're running Fusion. So there's this insert button up here on the top. This is just a new file. And down the bottom here, you'll see insert McMaster car. And then you can literally browse this and find whatever you want. I happen to have the numbers in here, 730 1K13. So this will take me directly to the object I'm looking for, and you click on product details, and then you can see what it is. It's got the little model, so this is the case, and then you just choose here. There's the what type of drawing or 3D object you want. So step is the safest bet there, so 3D step, just accept that, and then go download, and it just drops it straight in. You can obviously position, rotate, do whatever you want with that, but you can very quickly then see, you just keep going, insert, and then find another object, 2779K201. So that's the little circular guy. Oops, sorry. And then product details. It defaults to the right thing. Download, and it'll drop in as well. There we go. And we can bring that up. So then it's just a matter of extracting, the shape that you want from that geometry. But this just lets you test fit, get a good feel for the proportions and of everything. Make sure nothing's interfering with one another. Yeah, so that's the Fusion, like getting assets to Fusion. We've got a lot of other videos for creating shapes and exporting from Fusion, so we'll link to our tutorials for that. But that just shows you how to find these elements on the McMaster site. Right, so we'll go back to the slides now, and Adi will take you away with the next phase of using Origin in product development.
Yeah, thanks, Sam. That was a great demo. So yeah, we're going to spend some time maybe talking about Origin and product development. So at Shaper, the meat and potatoes of what we do is develop products. So we thought it would be pretty cool to show you guys how we actually use Origin in developing some of our own products, and how a lot of our Origin customers use Origin to develop products they manufacture and ship. So we're first going to look at Shaper Workstation. So now if you go to the next slide, yeah. So I'm sure a lot of people in this audience already know the Shaper Workstation. For anybody that doesn't, it is really an extension to your Origin, and provides a really efficient way to set up and hold work pieces. Yeah, and if anybody recognizes the model on the left, it's actually the vertical workstation that was designed and built by Noah a few years ago, and it actually the plans for it actually live on Shaper Hub even now. And the idea for the product we ultimately shipped as Shaper Workstation came from that. And looking at these side by side, you can really sort of tell the resemblance and see how we got to the Shaper Workstation from this wooden vertical workstation. And you can imagine that we sort of like worked on the ideas and in CAD land maybe, and evolved them to a place where we could ship it. Well, in reality, so if we go to the next page, in reality, we spent a lot of time iterating on designs early in the process. So, one of the things we we try to do at Shaper is really early in the development process, get all of our ideas out and really make them tangible. As engineers, we can tend to sort of live in engineering CAD and really sort of look at our screens and try and work through designs just in computer land. But one of the superpowers that Origin gives us as engineers is making these ideas tangible really quickly. And what that lets us do is make lots and lots of prototypes and iterate on them really quickly and really early in the process. And the reason we're able to do that is because it's so cheap and so fast to be able to do that. And so the risk of failure is very low. And so, this is just sort of some of the prototypes we made with Origin. You can see a lot of them are multi-material. We used engineering aluminum extrusion. If you guys want to look it up, it's called 8020. That's a really great material to prototype with. That in conjunction with plywood or MDF, you can make some really great functional prototypes. And ultimately, doing this process really early in our development life cycle helped us eliminate all the bad ideas and made the overall process of shipping Workstation super efficient and really effective. Yeah, that was Workstation. I mean, I hope that sort of opened the curtain a little bit to how we develop product Shaper. But Sam's going to take us to another story about a customer who builds these really awesome boats.
You kept it in like MDF land for quite some time, yeah, the Workstation. That was answering a lot of questions. Like there was some ideas you thought were bad that turned out to be good, yeah?
Yeah, absolutely. I mean, both ways, I think, we spent a lot of time debating and talking about ideas, but you can get lost in what's a good idea and what's a bad idea, and there's no better way to answer that than just making it tangible. So yeah, we made a lot of ideas in MDF and cheap materials, and as soon as you make something tangible, you can very quickly tell if it's a good idea or a bad idea. So there's a lot of bad ideas.
Get everyone on the same page nice and quickly. Awesome. Okay, we'll move on to the next slide, Noah. This is another customer of ours. I may butcher the name, Fitzk Boatworks. Sorry if I did, but yeah, he's doing some awesome stuff, making these incredibly sleek vintage boats, and he's used Origin. He's brought it into his workflow. We'll go to the next slide there. So this is a boat. It's going to be quite large. What we're seeing here is a 7-foot third scale model. So going from the CAD land, where it's a lot of profiles and things all in 2D, he then creates the full 3-dimensional model, and this enables him to test the construction, the flow of the curves, whether or not everything goes together as intended. He can even start looking at things like buoyancy and where the weight goes and how it will actually how it will work as a real full-scale boat. So this is like a lower cost, it's still pretty sophisticated way to flesh out his design and confirm that he's on the right path. So and at the end of it, he has a scale model boat to showcase the whole final thing with. What's great there is we'll move to the next one. It's not limited to that scale model approach. And I should make a note, like if you're working on a scale model, it's effortless to do at the tool. So you can design in full scale, and providing you have stock that's a third the thickness or half or whatever your scale ratio is, you can then just place your shapes. And actually we'll cut to my screen here, Noah. I'll just import something. And then we'll import that. So in this state, I'm placing a shape. This is my full scale object, but I may want to make it a different scale. So you can just go divide by 3 there. So this is a full calculator where you can manipulate things. And because they're linked, the whole thing is going to be scaled down. So now it's, instead of being 5, it's 1.6, 666, which is epic. You can just adapt, do a small version of something, get a feel for it without wasting a lot of material and cutting time, and then confirm or deny whether your idea was correct and move along to the full scale creation. What's cool is then, the full scale creation benefits from things like when placing shapes, nesting shapes on large, expensive wood. There's often, knots or blemishes, things you want to avoid for either visual reasons or structural reasons. Origin enables him to navigate around the blemishes, so he can nest and place his shapes literally right on the object, kind of the way you would if you were placing down, sticking down tape with a printout on it, but you then get the precision of Origin enabling you to cut that perfectly. So yeah, it's a really powerful way to migrate or continue to use Origin throughout the development of your project. And even things like the support structure for the boat, you can kind of derive that from, or you can design it explicitly with that in mind, or you can derive it from some of the shapes that you create with offsets to accommodate, the panels on the side and the fiberglass or whatever else is added. We've had other people working on boats who they created slots for an element to go in, but then they didn't consider the additional fiberglass and resin that would build up on that and eat into that kind of tolerance. So they were about to hand rasp it, but they still had the shaper tape on the element they'd cut. So we were able to just add an offset and then cut it like another 1/100th of an inch or whatever dimension larger, and continue to maintain that sort of digital precision throughout the whole process, rather than kind of a bodge job. That's the end of Kevin's boat, but I should make a note. Sing out if you want to dig deeper into this. We got another customer presentation here, and that's Justin Nelson, Fernwar. So he'll be participating in sessions not the following week, the one after. So he'll be able to answer more on that. But if you're interested in this project, we might be able to get Kevin to come on and talk more about that process. So it's always good to have the experts in here. Speaking of which, back to Dylan, the expert in developing fixtures.
Yeah, back on the engineering side, throughout the development of Origin, we constantly are validating every test, every new feature along the way. And so, this is the type of fixture we would make for mounting Origin and load testing, stuff like that. And so the thing I like about doing this kind of fixture is it's super quick. Bolt patterns can be done very accurately, very quickly. Again, arbitrary shapes cut out that I can design in CAD real quick, export. Some things like this can be done on tool CAD pretty easily. So, we can implement this type of fixture that's something that we can continue to iterate on or change. It's modifiable, being made out of wood. This spring I've got mounted on here, I can, move the mounting bolt all wherever I want by just drilling a new hole. And so Origin, this is a whole family of fixtures that we make in the development. I don't have any more to show here. This is just one example, but we have literally dozens of these we have made over the years in the development process. And it really, to me, it's a big win versus if I have to send something out for a quote, wait for the quote to come back, send out a PO, get a project back, maybe a few days, a week later, 2 weeks, if it's machine shops are busy or something. And I might also make it out of aluminum or something that would be harder to modify. Doesn't really, for this type of fixture, doesn't really help serve much purpose to make it out of metal. So, this is just a good way for us to make validation tests quickly and at low cost. I think that's all I have on that.
It's not all one or the other, is it, Dylan? You can be using both methods concurrently. You might be running a bunch of stuff quickly and cheaply in-house, and then something needs more rigidity or just a different manufacturing method. It might be water jet, it might be milled aluminium, you name it, something bigger and more elaborate. You can continue to draw on that, and even like we've combined 3D printed elements with origin cut elements, and probably outsourced like milled elements as well.
Yes, absolutely. I do that all the time. For like a big base on a fixture, I might use MDF, and I can cut out, accurate bolt patterns and through cuts with origin. And then for parts that need more accurate precision, I'll do maybe aluminum machine, like you said, definitely 3D parts mounted in there. Each of these methods has their own benefits for achieving the goals that you need. And I will definitely use the mixture of them that makes the most sense for speed, quality, precision, all of the above.
Yeah, I remember Maddie doing some work like developing just ergonomics and massing of the actual origin unit itself, and he could have waited like 24 hours for a 3D printer to produce a part, like basically the black base bit, or cut out a piece of MDF and spray paint it. So you can guess which direction he went. So that was ready to go in minutes.
Yeah, definitely the size of the parts matters a lot too, because if you get anything big for 3D printing, you can run a print for 24 hours or more. Whereas with a piece of wood, I might do an hour or two to get all the cuts and bolt patterns and stuff. It's nice when you can get something done and while you're working on that before you go move to something else. For CNC parts, typically there's some really rapid places that are more expensive that, take a few days. But if you want to keep the cost down, you're looking at sometimes a week, 2 weeks, really commonly. They get busy and booked up, and it's hard to keep the cost low on those. So it kind of depends on what you're sensitive. Usually trade off, between cost, time, and quality.
Absolutely. Awesome. Thank you. This next section is actually going to be digging into your manufacturing project. So this is like once you've prototyped and now you have something, you're moving to something you want to present or create the actual final product. We like to see the ways Origin can contribute there as well. So for the first, you can explain it better than me, Dylan. What are we looking at here in this this slide?
Yeah, well, this is a mountain unicycle suspension weld fixture.
Of course it is.
Before we get into that a whole lot, I'll just say, from an engineering standpoint, we are often involved not only in the design, materials choices, strength, all of that, but also how it's going to get made and how we're going to scale it up. And so manufacturing is integral to engineering. And so here we're using Origin to accelerate the prototyping of the manufacturing process. So this was a project a buddy of mine, Josh from Rapid Whale, was designing a mountain unicycle with suspension. So he asked me to come up with a weld fixture to locate these two sliding bearings 6 inches apart with fair accuracy and also nice and straight and parallel. And so, I have some tools at my disposal. I have, access to Origin. I have access to nice gauging and marking stuff, drill press, hand tools, even a little milling machine. But the fastest and best solution I could come up with for him was to grab Origin, a 3/4 inch piece of plywood, and on-tool CAD. And within about 20 minutes, I was able to, place these two holes that we had to make that mount a counterbore screw on a piece of wood accurately to 6 inches apart and cut them out. So I didn't have to go to a computer. I, probably just centered them on this piece of wood with the grid. I measured the bolt that needs to go in there and cut those bores to fit nice and tight. So we could repeatedly weld up a few of these things and have good equal spacing. And so if you go back to the slide, you can see the finished result of the weld there in a picture there. I don't have that part here, but Josh has that.
So that's going to be super unforgiving, right? Like if those are at a slight angle, it's just going to bind up, right?
Yeah, exactly. It's key that those are very parallel for their sliding motion.
Well, we've got some wood set up here. It's not. It's funny. We were describing this and how simple it is, which on one hand is it like very interesting to show people. On the other hand, the simplicity is the beauty of it. The fact that we can cut this. So you'll see down here, we got just a similar piece of wood as Dylan had there, 3/4 of an inch thick. I've swapped now to the stock 1/4 inch cutter. And we can look at my screen there now, nice. And I can now lay out basically mimicking what Dylan was doing there. So you'll see I'm just moving to a point on the grid that's 2 inches up from the bottom left. So at that point, Dylan's kindly shared with me his dimensions. So it's a 0.83 inch circle, and we place that there. So this is the shoulder he was showing you, and then there's another one that is 0.42. Dylan will correct me if I'm wrong for sure.
Yeah, that's correct.
Yeah, and then so that's at 2, and then we go to 8, and we can actually copy them. We don't need to re-enter any of that. It's selected the bottom left anchor. We'll keep it centered. So at 2 and 8, you can place that. Same again for the inside one. 2 and 8, place. So with that done, we can create the exact same situation as Dylan did there. So you saw the outcome. We won't bother actually cutting it, but we could then cut 2 of these and get those perfectly parallel fixture to just secure that metal long enough while we weld it. And this was like a relatively low volume, right, Dylan?
Yeah, this was just the beginning of the development phase for that. So we were making 2, but it's a valid manufacturing prototype to develop the process. If we were going to make 50 or 100, either Josh would scale up in his own shop, or he would outsource these things to someone else. And we could certainly share the way we did it and kickstart them on their roadmap, or maybe leverage their expertise, and they would have this stuff already in the bag. But we were able to get past the step of doing a couple of welds without having to go get some outside help for specialized tools or things that have to order and come back some days later. And this way, I was able to move on to the next problem that we need to solve in the roadmap of developing that product.
Yeah, it's one of those things where it looks to me like it would take longer to communicate the ask to a third party than it would to do it yourself. And then all the learnings gathered from the actual manufacturing of it would be lost on you. You wouldn't, I doubt they communicate back, everything that you need to take into account when you scale it up to the full production run, yeah?
Yeah, not usually. I mean, unless you were partnering with them to develop the process and you wanted to own it, you would set that up, as an agreement ahead of time. But if you just typically are going to send something out for welding, you're just going to get the parts back and either be happy with the quality or not. And, you're not really owning that process. Here we are sort of getting into what that process looks like, and we can decide whether we're going to keep that in-house, which maybe would make sense, or whether we're going to outsource that.
Awesome. Thank you very much for that. Okay, we'll move on to the next slide, Noah. This is Justin Nelson, who you'll see on Instagram. Ted should have a link there for you. He posts a lot of his development process, some of the materials he selects, and just you get a good window into how he works and what he's making. So you can see his latest chair there on the right that he's designed, and a lot of the development process here was done on Origin. So he was either cutting out the raw shapes and checking proportions, cutting joints, and you'll see like a lot of it is used in conjunction with like a lot of traditional machinery. So the key here is Justin works. He's got one employee, and they've got a modest-sized shop, and they just want to make their existing tools as efficient as possible. So you'll see on the bottom left there is a little fixture he's made. I'll bring these over. And I've sort of mimicked it here. The idea is if you can hold your... So say this is your cut object you want to make. This is like a big jelly bean version of his elegant design. So if I wanted to cut this, there is one path where you go and design this thoroughly in CAD. But if I've got this file ready to go and I want to just get a fixture to hold it in place, which kind of bridges the two worlds we've been discussing. There's the sort of ideation and prototype development phase, and then there's the manufacturing process phase. What you're sort of seeing here is the manufacturing process phase, but if it's fast enough, you could use this technique to develop your idea as well, just to literally make a few and test them. So I mean, it's cheap material, MDF. What's interesting here is I did all of this with on-tool design and using just this file. So with Origin, I placed a rectangle that was like a foot wide by I forget what it was, 14 or something. Placed the file, turned it from an outside cut into a pocket, and then pocketed down this area, and then did the exact same thing, or cut the profile. So that's what the following bearing on that slide you would have seen as big kind of shaper with a massive indexed carbide pattern bit, and yeah, down in the bottom left there. So then you attach this. So this is just a rectangle, basically exactly the same process as we saw with Dylan's project there. You would screw that down. Now you've got a nice safe fixture to hold things in place once that's attached. And now the only other thing to add are these little toggle clamps. So these are a great way to, we use them a lot of people use them in the field. You would, if this was thick enough, you adjust the screw on the end to get the right amount of pressure. So then screw that on here. That doesn't need any Origin work. And then you can just quickly bang, bang, get a process going where you run this through the shaper, the traditional shaper, and then you're cutting 1.5 inches of material in one pass. You just get a very smooth outline, pop your shape off, put it on the other side, and do the other 50% of it. And that's a way of making all the equipment in your shop that bit more efficient. You're not doing a lot of like laborious or sort of heavy concentration work on a bandsaw or something like that, and then sanding it back down or anything. You can get things really moving. So this keeps you safe, efficient, and consistent. So then this process can scale up to many hundreds. And you may, obviously you wouldn't use MDF once you're satisfied with the shape. I got some, you might want to use good quality ply. Some people add like a really wicking kind of a resin to ply to make it even stronger. So it kind of gets saturated and then sets hard. Or you can use that phenolic coated, I think I got some here. Phenolic coated won't look like much there, but that's ply with a resin and fiber kind of protective surface on it. So that's getting really durable, and you could create a large number of parts without ever having to replace that. So that's the end of Fernwa's little description. I hope that was clear. We can get into it more in detail, not this following week, but the one after. So if you have questions for Justin, get them jotted down. Obviously, you can ask us things about it, but yeah, he'll be here in 2 weeks, and he'll be able to go into a great deal of detail on this. So we'll get back to Ari to look at one of his projects.
Yeah. So something I want to talk about. We've talked about prototyping in many different parts of the product development process and also the manufacturing process. And a lot of the prototypes we've looked at is about prototyping the entire product as is. But an approach we use at Shaper all the time, to make things faster and to get to sort of these the answers really fast is. Rather than prototyping the entire product, what if you could just prototype a part or a small part of the project? So, when thinking through this, something I like to do is as soon as there's an idea, you're starting with that, rather than coming up with maybe a prototype for the entire thing. What's a burning question you have about the idea itself? Is there something about it that is lingering? Maybe it's a design question. Maybe it is this particular material going to be strong enough? I'm sure a lot of woodworkers out there actually sort of do this all the time. For example, will this particular glue work with these two dissimilar materials? That's sort of almost a part of a prototype you're doing to test that hypothesis. And we can sort of take this further by really thinking about the prototype as an answer to a specific question. And something I like to do, to really think about these, what the right questions are to answer, is think about, what the critical function of that product you're trying to build is, and also the critical experience. So, for example, if we were building a chair, one of the critical functions of the chair is, maybe it needs to bear a certain amount of weight. Now, maybe we don't need to be building the whole chair in its entire form to figure out, if the joinery we intend to use can carry that weight. Is there a scaled down version of this we could build to do that? And a critical experience of a chair might be, how comfortable is it when I sit at it? Like, what's the angle of the backrest at like? And one way, to prototype that is, just sort of look at different backrests at different heights and do that really quickly with a dummy model rather than having to build 5 different iterations of the chair itself. So maybe to like drive home this idea a little bit, I'd like to show a project I worked on a couple of years ago. So now if we go to the next slide, actually here we can show this right now. So it's actually a stool I worked on. Funnily enough, I built this project as a test project during the development of Workstation to test how effective the work holding on Workstation actually was. So this is a 3-legged stool. It has some interesting joinery. It doesn't meet in the middle, and the legs sort of end at the top. And the top is made of corian. So if we go to the slide really quick now, so the project, we're looking at a finished project now, so it's easy to see where I ended up. But it really started with this sketch. I just had this idea for a stool where the legs don't meet in the middle, and sort of you get this clean transition line between the legs and the top. And something, one way to approach this would have been maybe open a CAD design tool like Fusion 360 and make a bunch of models. But the problem I always find with that is it's easy to get lost in the details and not really sort of figure out the crux of the problem. And one of the problems I had to figure out with this tool is like, what does the joinery and the interface look like at that top edge? So if we go to the next slide now, so this top edge where the leg, the hickory leg meets the corian, is I sort of imagined in my mind what that might look like, but really without building it, I couldn't have worked out all the problems. And so, started with a bunch of sketches. And rather than building 5 or 6 iterations of the same thing, I actually just sort of just took this small intersection of these two components and figured out, with just on-tool CAD, quick iterations of these. So unfortunately, I don't have, all the prototypes I made during that time because, hey, they were cheap and made out of MDF, so I threw them away. But I did actually create really quickly on tool today. It was literally 20 minutes before a session, a version of this. So you can see this is just some, scrap plywood I had lying around, and I had this piece of oak that happened to be sort of the right size. And I just prototyped just that one intersection, right? And so I can see how that feels. If I wanted to test the glue strength of just this joint, I'd glue that and apply some load to it and see how that feels. And I can answer that question for this interface without ever having to build a prototype of the whole thing. So that I think thinking about your projects that way and breaking them up into small chunks can really be an effective way of prototyping something. Sam, I think you've got some other examples right there with you where you've done this process, right?
Yeah. This one's kind of fun. Let's see here. How long we got left? We've probably got about 3 minutes, so this one will have to be quick. But so I made a little. This is a handle for a kid's art station. So the final one looks like this. This one, I've got a little curved sprockety thing that enables me to mount it and drive a rod, a dowel. But these are, really, really handy. But I mean, to get there, I don't need to, do the elaborate version. I first need to see, my daughter's hand's going to catch on stuff underneath. Does this attach and drive this properly? What's my, my cutting workflow? This was actually quite fun to. I made this little fixture for holding it in the workstation. I'll just pop it to the side and show you what that looks like. Now it's got 2 pins that go into the can we see them there? Maybe not. That make sure that it indexes at the right place every time. So that's not going anywhere. And then I can just with the regular clamps and everything, mount in here and torque that up and cut. I actually you can see here. So I probe here and here to do a grid, and then here. So that gets me a grid that's at 45 degrees, which is a bit weird. But then to find the center of this, I just measure it, and I can enter the radius of my dowel, enabling me to then place a circle, any size circle, in here, within reason. So that's one handy little thing, and it lets you sort of manipulate it a little bit. Keep in mind these dowels are notoriously non-circular and or non-cylindrical, and they often don't match the dimension they say they are. So it's good to be able to adjust that. The grid, you go modify and set it to a different dimension there. So I'll actually just return to a workspace that shows it, so you can see what I mean. So there's my grid and the shape I'm cutting, and you'll see if I go grid, modify, I can adjust my grid dimension and then place the shape again to get the correct alignment. So that's just one handy little thing for working with end of dowels quickly and easily. So that's the end of prototyping with Origin. Obviously it's a very high level sort of bird's eye view of a wide array of different domains that Origin really raises the bar or gets you productive and gets you the answers you need quickly. Thank you, Adi. Thank you, Dylan. Hopefully a lot of relevant stuff that can influence the way you work with Origin and get the most out of it.